All right, I have one last concept related to inheritance to discuss, and this can be useful in this situation where you have things like one type of reference variable referring to a different type, a derived type of object. So like our situation here, where we were iterating through our list of all accounts, and we were getting the objects out, and some of them were rewards accounts, some of them were checking accounts, but we kept assigning them to this variable over here that was a checking account reference. We ended up sometimes where this reference was referring to an object like this one right here that actually was a different type. Okay, and so we can end up with one limitation of that type of situation. And so I'm going to jump over to this code and make this hopefully clear. So we end up with a situation like this, where we have one type of reference variable referring to a derived type of object. So checking account reference referring to a rewards account object. And so we know, hopefully by now, that the type of the object determines what data is actually in the object. So this data is a rewards account, so it has all of the normal data for a checking account, plus it has points and a monthly fee. But we know that the type of the reference variable determines which methods we can call on the reference variable here. And so here's our problem that occurs every once in a while. What happens if we want to call on Adam's account? We want to call the method charge monthly fee, which we know is something that can occur with a rewards account. So we've got this rewards account over here, and we want to call this method on it. Well, right now we couldn't do that, because again, the reference type determines which methods can be called. And a checking account class doesn't have the charge monthly fee method. So this would not be possible using this type of reference variable. So when we end up in a situation like this, we're now limited. We cannot call certain methods that we might want to call for the particular type of object that's being referred to. We could not do this. So there is a solution to this when you run into this type of situation. And the solution is very similar to this example up here of something we talked a long time ago about casting variable types. And so this example shows we have an integer called x that contains the value of 5, and then we're taking that value x, which has the value 5, and we're assigning that to a different type, a double. And we can do that, we can cast. Okay, that's what this means, if you remember. It's been a while since we've done much of this, but we can actually take a value of a certain type. This is actually an integer, contains the value 5. We're casting it to a double. And so now we can assign that to a double. So in other words, y will now have the value 5.0. So if we do our little memory diagram over here, x has the value 5, y now has the value 5.0 because it took an integer 5, cast it to a double, which means convert the type. And that's a legal conversion to do that, cast an integer to a double, and then we can assign it to a double variable. We can actually do the same thing down here. So we can cast a type, okay, when we have a situation like this. And we can actually say, instead of writing this code right here, we can actually do something like this. And you have to be careful about this. But since we know, in this case, that the actual object type that Adam's account is referring to is a rewards account, in other words, it's got all the rewards account data, we can actually do this. We can say rewards account, this is the cast part, Adam's account. And what that does right there is it takes Adam's account, which is a variable of this type checking account, and it casts it. So now it becomes a reference variable of type a reference to a rewards account. And what that enables us to do is that now that that has been converted to a rewards account type of reference, which we know makes sense because we know it's actually pointing to a rewards account object. Now that we've done that, now we can call methods like this. We can call any methods that are available to a rewards account. And so what we can do now is I'm going to go ahead and I would put this all in parentheses to make sure that that cast happens first. And now I can actually say dot charge monthly fee. Okay? So not only can we cast little primitive types like doubles and ints, but we can actually cast other types as long as it's something that makes sense to do, like casting this variable type to match the type of the object it's actually pointing to when we have these derived and base classes. So it's something that in this case, hopefully you get at least the concept of how that makes sense, that would be possible to do. And then you'll see certain situations, and you might even see this potentially on your final project, where you are dealing with situations like this where you're pulling objects out of an array list of different types, and you might need to cast the variable that refers to it to a different type so you can call certain methods on it that are only available in that derived class type.